This homework required you to go back to the other page, well, to the other side of the page, and find out the information. The majority of my fourth period did it exactly right. My second period was completely clueless because they didn't know how to read the last part. And my third period was like half and half. So hopefully this period read um, what it said to do and not just assume that like, oh, I don't know what this is, and completely ignored it. The other page had exactly the example of what you needed. So let's read the question. Glenda's taxable income is $26,222. She paid $2,640 in federal withholding. Find the tax due on Glenda's income. Tell whether she will have to pay an additional amount or will get a refund. Use the tax table in example 3. So she has a total of 26,220. Oh, I hate this thing. Hang on. So she has this much money in taxable income, right? You have to find the bracket. Everyone has a specific taxable tax that you have to pay if you're within a certain bracket. So you will have to go and find that number, 26,222, in this table. Where is it? In the first one, right? It's between 26,200 and 26,250, right? It's right in the middle. It's somewhere in there. That means that she was supposed to pay this much money in taxes, right? 3,509. How much did she pay? Look at your book. Don't look at my face. There you go. Now tell me, will she have more to pay or did she pay too much? 869 to be exact. That's how much money she has to pay to the federal government after for that year because she only paid 2,640 and she was supposed to pay the amount that it says on the table. That was a very easy question, but you had to read the last part where it says, look on the table in example 3. And somebody asked me, where's example 3? And I'm like, here. You have to read it. You have to actually read the question. But some kids expect everything to be there. It makes no sense. All right, for the next one, I think a lot of people actually did it correctly, unless you didn't round, or you rounded the wrong way. So what do you get for the first one? Depends. What? 0.86 in the tax, and what's the total then? And what is the tax for the next one? 32. If you got 31, that means you did not round. What's the total? 4.30. And the next one? 3.60. And the next one? Total? So what is the total? $70.08. This is literally, you just do a little P over W for all of them. And that's it. You do it individually. 8%, 8 over 100 equals X over 1077. Cross multiply, divide by 100, you get the number. And then you just add those two and it gives you a total, right? Do we have any problems with this one? Most people get this one right. All right, the next one, that's the one that I did not quite like from my second period because everyone acted like they didn't know what to do. Juan earns a monthly salary of $3,200. Federal withholding is 14.1 of this gross pay. Juan has a total of $244.80 deducted from Social Security and Medicare. Find his net pay. What do you do? What do you use for that P over W? You use a 14.1 over 100 And what do you do? What do you get when you do that? That's not it. You get 451.2. 451.2. Do not forget where your decimals go. And that's only for the federal withholding, right? Now what do you do? Why on earth would you multiply anything in here? Thank you. You add it to the deduction of 244. Every time, guys, and let me make this very, very clear. If you on the test, if at any point you catch yourself guessing, stop. Just stop. Because as soon as you start guessing, you're going absolutely the wrong way. Think about the problem first. All right? So when you add those two, because of deductions, you end up with $696, right? Then you take that from the gross income, and that gives you the net pay, right? Of 2,504. As you notice, this person did not get paid very much. Sure. Okay, I agree. Lizabetta's taxable income is 26,380. She paid $2,140 in federal withholding. Use the problem model to find out basically how much will she have to pay in taxes. So this one happens to be on the very bottom of the table, right between here. So she was supposed to pay 3,531, right? How much money did she already pay? What? So she's gonna pay $591, right? So as you notice, you don't always get a refund. Sometimes you gotta pay back. Good. All right. Do we have more? Okay. Just go back to your scrub back with your neighbor, whoever it was. All right. So the next part is gonna be interest. Let's make it fast. Sorry. Thank you. The next part is going to be interest, and we have two types. We have simple interest, and then we have compound interest. We will go over both of them today. And simple interest, as it sounds like, it's pretty simple if you pay attention, if you get it. If you're not paying attention, you're going to get lost very, very easily. What? So it says Roberto's parents opened a savings account for him on his birthday. The account earns simple interest at an annual rate of 5%. They deposit $100 and will deposit $100 on each birthday after that. Roberto will make no withdrawals from the account for at least 10 years. Make a table to show how the interest accumulates over 5 years. So in the first year, this one, you had no money, right? Then they added $100. So your new balance is $100. Then you do a P over W with that. What is 5% of 100? P over W, you end up with $5, right? That's what you make for 1 year. On the second year, they use the same amount and they add another $100. So you end up with $200, right? When you take the 5% of that, you get $10. On the third year, they use whatever they had, plus the new $100 they added, and now you have $300. You get 5% of that, which equals $15, right? On the fourth year, you do the same thing. You get $20. On the fifth year, you do exactly the same thing, and you end up with $25. Yeah, so basically each year it increased by the same rate because you're adding the same amount every year. You're adding $100 every year, and the tax rate is the same every year. So you end up earning a total of $75 in just interest right here because you add all of them and you get $75. That's just interest. How much money does he have in addition to that? 500, right? Whatever he added. All of this that he deposited every year, it's $500. So how much money does he have total? 575, right? Good. So how can you figure out how much money, how much interest he would earn in 10 years? Huh? It's not double because you notice that the amount increases every year. It doesn't stay the same. What? You can't do that. Tell me. But you have to continue the whole trend, though. Look at the pattern. Look at the interest. How is it going? So what can you do to get to the 10th one? Thank you. Just keep going. Well, I'm sick of it. So what? So if it goes on, where would it be for year 6? What is it for year 5? 30, yes. 600. Yes. You will have another 100 here. You get 600, and that will be 30, right? So this is what you do. You create a little table, and you put deposit, and you put interest earned. You deposit another 100, right? And for that year, it would be 30. And then another 100, and what do you get? And another 100. And then the last year, there you go. So how can I figure out the amount of earned that I earned the entire 5 years? Add them all up, right? So go ahead and do that. Add them all up and give me the total amount that you earned in interest and the total amount that you got in money. Okay, so when you add these, what do you get? 200, right? Then you add the 75 for the first 5 years, and you end up with 275 as your total. So that will be only for the interest, right? So how much money will she have? Total. 1,275, right? If you notice, this person did not earn that much money in 10 years. That's a long time to wait, and you only earn 275. But it's better than having nothing. All right. So you're going to do the same thing with the your turn, number 2, with Amy. Go ahead and do that. Okay, so let me explain how this works first before I send you on your way. To get the amount earned right here, you have to multiply the balance times the rate in decimal form. 0.05, right? So 100 times 0.05, it gave me 5 actually, after you move the decimal and everything. And then you multiply that by the year. So 5 times 1 is 5 for the first year. 5 times 2 gives me 10. 5 times 3 gives me 15. 5 times 4, 20, and so on and so forth. So to find that one, it's 8%. What are you going to multiply 100 by, which is your principal? 0.08. 0.08, right? And that's going to be for 1 year. So then you do it for the second year and the third year and so on and so forth. Let's go. For 1 year, let's do a little table over here. For 1 year, he deposits 100, right? And he gets how much money? 8. For year 2, 30 what? 40, right? So how much money did this person earn in, how much interest did they earn in 5 years? 120, right? So how much money did they deposit? 500. So how much money does he have total if he takes it out? 620, right? 620. Good job. That was easy. That's called simple interest. Wait for the next one, which is evil. Basically, notice how the increase of interest is different. It goes from 5, not to 10, but to 10, 25, to 15 something, 21 something, and 27 something. It does not go by the same amount each year because it's not simple, it's compounded. In other words, the balance is different too. Look at it. You will not, there's a formula for that, and you probably will not be given this kind of questions on the test because you need a calculator for that. And you will not be given one, so it makes no point. It makes no sense to do that. However, you need to know the difference. This is called compound, and if in your brain you can connect compound to complicated, that's going to help you. Simple means easy. Compound, complicated. So the difference between simple and compound is the simple gives you a fixed rate. The whole time it'll be the same rate, the same increase, right? Like we did the other one by 5, and the other one by 8. For compound, you get a different, it's the same rate, but it's a different increase every single time. But it grows faster. So notice how this person with the same amount of money and the same rate earned $85 on the first year, on the first 5 years. The other one only earned 75. So as we go bigger and bigger, you notice that the rate at the end for, the interest rate at the end that this one earns is a lot bigger than the one in the simple. So in a way, this guy is better because he gives you more money. However, it's harder to compute because you have to compute it every single year. You have to redo the whole thing. So in other words, every year, if you notice on the other one, it's the same balance. He goes by 100, then 200, then 300. On this one, it's adding the interest to it and multiplying it again. And then adding the interest to the whatever you have and multiply it again. And you end up with all these decimals. I don't think you'll see this on any kind of testing because you don't have a calculator for it. But you need to know the difference between the two. That's the formula right here. Principal times 1 plus the rate to the power of time. Yes. I'm sorry? Because you're a 7th grader and you're not doing calculations that they're required to use a calculator. That's for pre-AP because you're doing advanced mathematics. That's different. They're not doing your stuff. They're doing 8th grade, period. You're using the 8th grade books. And that includes a lot of stuff that you cannot do by hand. I mean, you can, but it will take you forever. Mm-hmm. No, well, unless you score really high on the star. Okay. All right, so this one shows you an example of how interest rate is calculated for simple interest. Again, you're just multiplying whatever you start with. You multiply it by the rate in decimal form and by the year. For simple interest, if it's compounded, then you get a higher, you get a different kind of calculation. And I'll show you right here how that looks like that in step 2. It's just too crazy. And they don't show you how they break down the second part of it. But it's a big thing. If you do it by hand, You basically, every time you multiply by a power, like if it was 2 to the fourth power, that means 2 times 2 times 2 times 2. And then you go 2 times 2 is 4, and then times 2 again, that'll be 8, and then times 2 again, 16. Well, that's easy, right? But when you have a number like 1.05 to the power of 10, that's a lot of work. And it gives you a lot of room for error, which makes no sense. They will not give you this thing. They probably just give you the tables completed already, and you have to look at them. So be able to analyze it. Where are they at which year, and how much interest has been earned at which year. I want you to focus mainly on these parts. This right here, the ending balance and amount of interest rate. So for the first year, you've only earned $5, right? By the second year, you have not earned $10.25. How much have you earned? I'm gonna ask you one more time because I think my question wasn't very good. So if I ask you how much interest have you earned in the first year? $5, right? Right there. Interest earned, right? That's how much interest you earn in the first year, $5. If I ask you how much money have you earned in 2 years, what would it be? Wrong. How much interest have you earned? Total interest have you earned? Interest only. Where are you getting these hundreds from? Wow, this is crazy. But that doesn't mean I ask you for the interest specifically. How much interest have you earned in 2 years? What? I am really shocked. I'm going to ask you one more time. How much interest did you earn in 1 year? How much interest have you earned in 2 years total? You earned 10.25 on that one second year, just for that second year. Oh, thank you. You already earned that one. You have to add this one right here. Yes. You would totally say 10.25 on the star, and I'll be like, really? Yeah, you add them up. Same with the simple interest. You did not just pick one. You added the whole thing. Here. See? You added all of them, right? Then why were we not thinking that? People. Okay. You're going to get this one for homework. 9, 10, 11, and 12. 9, 10, 11, and 12. Not 13. All right, and we're going to the next section. Can't even talk. All right, the next section is the following, guys. It's talking about unit rate. Basically, what decisions you have to make if your parents send you to the store to buy groceries. So I'm going to use a very common example. Let's say your parents send you to Fiesta to buy tortillas. And y'all know that they have like very different kinds and very different sizes and prices. So let's assume that they don't care which kind you buy as long as you get the best value one. So you walk in there and you have one What did I put right here? Hmm. Let's pretend that you go into the store and you find one that is 2.5 kilograms and it costs 3.75. Another one that costs is 1.5 kilograms and it's $2. And then the last one that is 3 kilograms and it's 4.50. How? Prove it to me mathematically. Not necessarily. You can't really see it that way unless you do something specifically. Yes? The last one has more kilograms, but it's also more money. Plus 2? Yes. Well, you can't just add kilograms. Yes. Okay. Are you sure? If you multiply 1.5 by 2, it gives you 3. Then you have to multiply the price. It'll be $4 if you double it, right? So you think the last one is better deal? It's more expensive. You can think about it that way, but to prove mathematically, what can you do to find out which one is a better deal? You can't subtract. You can't just start guessing. Look at you. Think about it. What can you do? You can find the cost of 1 kilogram. Oh, I said that at the beginning. By the way, this is the only class who did not give me that answer. Everyone else gave me that answer. So I have to give it to you. You have to find how much 1 kilogram costs in each of those situations. That's the only way for you to figure out which one is the cheapest one. So go ahead and find how much 1 kilogram is by doing what? What do you divide? The price by the kilograms, right? Go ahead and do that. The first one for 1 kilogram equals $1.50. The second one for 1 kilogram, $1.33 because it repeats. And the last one, 1 kilogram equals what? $1.50. Wow, some of you don't know how to divide. So, which one is the better deal? Clearly, the one with the lowest price per kilogram, right? Which one do you pick? Why would you pick the first one? It's not, guys. We broke it down to where you see the value of each piece. That is the only way to know which one is more expensive. It doesn't matter. If you eat a lot of tortillas, then you can multiply this by 2, and that gives you 3 kilograms for $4, which is still cheaper than that guy or the one on top. Well, as long as you found the one that was cheaper, yes. So guys, when you're comparing things, if they ask you which one has the best value, then you will go for the one that has the cheapest unit price. If they ask for the one that is the most expensive, then you look for obviously the one that has the biggest unit price. It's not very difficult actually. So let's see if we have any in here that we can compare, because I don't like some of the problems in here. Oh, we didn't get to that one, but example. Use this one. Use the example 3 to do number 5. You're basically trying to figure out which one's cheaper, an item that has a percentage off or an item that has money off. You have to calculate the percentage off, right, and compare. So for the one over here, oh, I didn't do it. Darn it. Did I do it? I didn't do it. Okay. Anyway, for the other one, I give an example of like you're going to buy shoes. And at one store, the shoes are 15% off. No, 35% off. And the other store, the shoes are $15 off. Which one is a better deal? No, I said 35%. Did I, what? Somebody said something over there about the price. Exactly. It depends on the price. I didn't give you a price. So you don't know. But if the shoes were $40 and they were 30%, 35% off in one store compared to $15 off on the other store, when you calculate that, it actually turns out that 35% off is cheaper because it has a lot. It's $16 that they're taking off compared to $15. So what you're gonna do for this one is exactly that. What is wrong with this thing? That's too bad. Oh. Oh well. I don't know what happened. Anyway, so the point is that you're gonna have to use your knowledge of P over W to find the percentage off. Hello. Which is something that you already learned last semester, and to compare them, which one is a better deal. So for those of you, oh, it froze. That's what it is. Those of you watching the video, that is your other homework. Everyone else, you may put up your books. Yes.